So one of the first uh, devices that we talked about, studied, was the diode. Okay, and we talked at that time that the diode can be thought of as a switching device. That is, it switches current when it goes in one direction and switches off when it tries to go in the opposite direction. So you can say that the diode is a switching device. The transistor, the bipolar junction transistor, can do the same thing, but you can actually, in a bipolar junction transistor, you can have an AC signal as well. So you can have the switching being on for AC, or you can have it off for AC. Okay, so that the transistor can be thought of as a switch as well. You switch it on when you activate it with a small current through the base, and you switch it off when you don't have that condition. Okay, and but in the case of a transistor, you also get some amplification as well. So that is, you can say that the transistor can be used as a switching device for AC. Okay, uh, but and you can also think of a field effect transistor in the same way. It's still a transistor, but it works on current rather than on voltage, right? But today's topic is thyristors, and thyristors are concerned with switching devices, but therefore higher energy waveforms. And also some of the more sophisticated thyristors can be used as waveform building devices, okay, which you'll study in the presentation today. The presentation is structured so that you can take a break in between the different components so you can catch up, think about them, and then go on to the next component. You know, complete your note taking, and then go on to the next one, and so forth. So it's not going to be a long lecture, but there are a lot of interesting uh, thyristor parts that you can learn about. The chief one that's used most often, of course, is the initial uh, silicon control rectifier. And a silicon control rectifier you can think of as being a diode that allows, though, for AC signal to be rectified in one direction, but you can switch it off at, when you want it to. You can switch it off and it stays off, or switch it on and it stays on. Okay. So, and the others work similarly, but the more sophisticated ones can allow you to switch off at particular points in time or during the wavelength, during the waveform, okay, during the actual sinusoidal time. So that's all there is for today, and tomorrow we will go through, we'll start with photoelectrics.